dancing and refreshment 4 days from now. Sophie hadn't attended a social event in months.
Morning. Morning.
Morning.
Morning.
See if we get some more people. First, any questions or concerns? So like I said last week, I'd like to finish the pulmonary system and not have lab today, but continue with lecture and finish and work on the urinary system. Also, if you've got the materials needed for the urinalysis, as we go through the urinary system, let's discuss those. So we'll do that this afternoon also. Any questions, thoughts? Yeah, I understand it's early in the morning. Let's get going. So my notes say that we were on 66. So just a little bit of a review. Dalton's law is that all of the different gases in the air have their own pressure. Each gas exerts its own pressure. And that the atmospheric pressure that you feel is a sum of all of those pressures added together. What that also means is that when you have a mixture of gases, just like they all flow from a high to a low concentration of their own gas. So we've talked a lot in the past about things always moving from a high to a low. Each gas does the same thing. So the pressure of the oxygen within a compartment if that pressure is higher or lower than that of another compartment, it will move accordingly. Same thing with carbon dioxide, same thing.
Hello?
with
My goodness, is it working?
Same thing with nitrogen. Any questions about this idea?
You know, I'm going to use my iPad. This is not working for me.
Also, when the gas is wetted, when it gets wet, as it moves through the nasal cavities, it lowers the pressure. So if you think about it, if you're at atmospheric temperature where you're at 760 torr or 760 millimeters of mercury, 78.6% times 760 torr says that the partial pressure of nitrogen gas is 597 millimeters of mercury. When it gets wet, the percentage of the gas drops, and accordingly the pressure drops also. So 74.9% times 760 would be around 569 torr. Inspired air for oxygen gas, 20.9% times by 760 is 159 millimeters of mercury. When it gets wet, it's then 104. Water, same thing. Carbon dioxide, 4% of the atmospheric, thus the inspired air. Atmospheric air is what we're going to inspire and breathe in. At times 760 is 0.3 millimeters of mercury. However, when it gets wet, when you solubilize carbon dioxide, it's more soluble in water. So let me re-explain this a different way with regards to the water. This percentage here is also is a measure of how soluble that gas is in water. So if you've noticed here, nitrogen gas, 78%, once it's wet, it goes from being 78.6% to 74.9%. Oxygen, 20.9% goes to 13.7% because they're not very soluble in water. It's a measure of their solubilities, how their pressure is going to change when they're dissolved. Water at 0.5% is obviously soluble in water, and it jumps to 6.2%. Carbon dioxide is more soluble in water than oxygen or nitrogen gas. So when dissolved in water, it jumps to 5.3%. Is this clear how this works? Becky, you're the only face I can see right now. Is it clear?
I'm here. Yes, it is.
Yes.
Yes. Mhm.
So pressures change based on what your altitude. The pressure is going to decrease as you move up in altitude. The gas composition stays the same, but for example, at sea level, we're at 760 torr. Once we move above sea level, we're maybe at 700 and as it goes up in pressures, or goes down in pressures as you move up. So different altitudes. Then if you take the partial pressure, remember it's 20.9% of the total air is oxygen. So the partial pressure of oxygen at 707 times 20.9% gives you a partial pressure of the oxygen to be 148. Because it's not as soluble in water, it's going to be 97 once it's in the alveoli. Another law, Henry's law. Henry's law states that gases dissolve according to their solubility and their individual partial pressures. So with regards to this law, an example would be you introduce a gas to a flask, and that gas, oxygen gas, has a partial pressure of 100 millimeters of mercury. As it equilibrates, they will equilibrate, and the gas will continue to move into the water until both the overlying air and the water have a partial pressure of 100 millimeters of mercury. Oxygen is fairly soluble in atmospheric air. It mixes well, it mixes easily. However, in water, it's not soluble. It's not very soluble. And so here, I'm going to enlarge this just a little bit. Oh, that's not, bear with me just for a second. I have a lot of different things showing up here. I want to do. So looking right here, you introduce that air. Initially, the water has no air in it. But within a short time, they're going to equilibrate, and the partial pressure within the water is also going to be 100 millimeters of mercury. Even though air is very soluble in air, it mixes well with air itself. In water, it's not very soluble and has a much lower concentration. In contrast, we introduce a partial pressure of we introduce carbon dioxide, which has a partial pressure of 100 millimeters of mercury. It equilibrates, and both the air and the water both have a partial pressure of 100 millimeters of mercury. even though carbon dioxide and carbon dioxide and oxygen have the same solubilities in air. In water, carbon dioxide is much more soluble. And so the solubilities of the gases may differ, but their partial pressures are the same. So Henry's law is that they're going to equilibrate. They're going to dissolve in proportion to their own partial pressures. And they're, even if they have varying solubilities in water. So I'm going to give another example. I'm going to combine an example here. So I have a beaker. And rather than just put carbon dioxide and water in it, so rather than just using carbon dioxide or just using oxygen gas, I'm going to do 2. Oh, you guys, you can't see me, can you?
No.
Darn it. All right. Thank you, Rachel, for saying something. Let me see.
You're welcome.
Becky, I'm sitting there saying that I can see you when you can't see me. You don't say anything?
Well, my dogs are absolutely wild. I can't even focus this morning.
All right. I understand.
It's I think the rain is killing them because they can't run around outside. So they're terrorizing my bedroom.
Is it raining there?
It did for the last couple of days. So the backyard, today's the first day they can run, but it is like so muddy. I mean, we have 5 acres, so it's pretty muddy.
All right. Let's see here. Stop sharing. All right. Why are you being strange? Let's see here. F9. Let's try this. It might be F7. All right. We're going to make a quick call to my dad. See if we can wake him up. Because I don't want you not to be able to see me.
It was working and then it just goes black.
You
Well-
can try logging back out and us logging back in. No.
I think from what I remember my dad telling me let's try this.
Did you turn your camera off?
I didn't.
Okay.
Oh,
Yeah, it says your camera's off.
I'm noticing that, and I don't know why it's saying that. And it's telling me to start it by clicking Alt V, and of course it's not working. All right, just a sec. Bear with me just for a second. Hopefully he'll pick up. Hey, really quickly, I'm in class. I'm in my online class.
I can't hear you.
Dad, I'm in my online class.
Okay.
And my video camera is not working. And it's
Plug it on, plug it, restart the computer.
restart the computer. Okay, guys, I'm logging out.